It's a pleasure for me to introduce Florian Lautenschlager, who will give us a talk about Chronix DB.
Thanks for introduction. Welcome everyone to the last talk of the conference. Chronix is a fast and efficient time series database. Well, it's a very small audience, so thanks that you're still sitting on your chairs. I'm the founder of the open source project, Chronix, and I'm also a guest researcher at the University Erlangen-Nuremberg and work as a software engineer at QAVA in Munich. And in my research, I want to find ways to reduce the time that is needed to find bugs and fixing them. And for that, we're using time series, and the time series represent the resource consumption of a system or a cluster. And we have a tool called software EKG. And for example, one can see the memory consumption of two different hosts. And one can see that here's a spike on LE up 38. But that is not the topic of the talk. The topic of the talk is the underlying storage or time series database that allows to build such a tool. And I want to start with the question how to store 68 billion time-correlated data objects on your laptop computer and retrieve any point within a few milliseconds. Any ideas? What could be approach for that? A simple approach could be with a relational database management system, and a simple model like that. We have a time series, we have a table for the data objects, a table for attributes, the metric name, and the logical measurement series to group time series that belong to a measurement. This approach is no rocket science, and hence one has slow imports. One need huge amount of hard drive space. The retrieval of the time series is also slow, and one has limited scalability due to relational database management systems, and of course one has missing query functions for time series data. And in my free time, I love to go sailing, and if I want to explain how that approach felt, I found a nice picture. But what to do in such a situation? It's very simple. We only have three key ideas which combined solve the problem. And the three key ideas are: first, if you have a time series with about 68 billion data objects, split them up into chunks with the same size. For example, split them up into 1 million chunks, and each chunk contains 68,000 data objects. Then compress these chunks to reduce the storage demand. And the third key idea is to build such a record with a start and end, describing the chunk, the first point and the last point, and arbitrary attributes that describe the chunk, so one can find the chunk by querying after, for example, a host called LEUP37. And the reason that this approach is a success story is that we are able to store 68 billion data objects in 32 gigabytes and retrieve any point within a few milliseconds. And I've done this measurement on my laptop computer, no server computer, no, just a small laptop computer. And we're able to search on the attributes without loading all the binary data. which also gains faster queries, and everything runs on a laptop computer, and many more reasons. So that's all. And it's the last talk. I have to go to Nuremberg tomorrow, have a meeting in the morning, so are there any questions? No, just kidding. What comes next? I want to introduce what are time series, what is a time series database, typical features, and the stuff, and why did we choose Apache Solr, and are there alternatives? I want to introduce the architecture of Chronix, and I want to show what is needed to speed up Chronix to an ideal performance. For short definitions, a data object is a pair of timestamp and value. And in my definition, the value could be any kind of object. For example, you can also store a trace or a log or a thread dump, whatever you want. And not only scalars. The second definition is simply the time series itself. Time series is a ordered list, chronological ordered list of data objects of one value type. Definition 3 says what is a chunk, as Chronix heavily works with chunks. It's a chronologically ordered part of a time series, oh wow. And definition 4 simply says what is a time series database. Time series database is a database that is optimized or specialized to deal with time series data. That's all. A few features of time series database, I have arranged them in 4 groups. We have data management. It's well known that time series database rapidly grows to gigabyte, terabytes of data, so hence one need strategies to deal with that. For example, round-robin storages. One has to downsample old time series, one compress the data, or do a compaction like TSDB does. Performance and operational is the second group. And time series have a special characteristic that updates are rare. So, especially in the case that you monitor a system, you're doing no updates to your data, typically. And inserts are always additive. We need fast inserts, as typically nowadays systems are distributed and produce tons of metrics per second, so one has to store them fastly. And even for an online query processing, one need also fast retrievals. Time series databases are typically distributed and have a high efficiency per node. That's the wish. And there's no need of ACID, but the data should be consistent in a cluster. As mentioned, attributes are important to describe the time series, to give them a context. For example, the time series from that measurement are based are collected during a load test, for example. Or you have to define which host, which process, which type, or even for the data object itself. So what is the scale, the unit, and where does the data come from? For example, is it collected from the operating system or from JMX, for example? And furthermore, to work with the data, one needs specific time series functions. For example, one needs statistics like aggregations, minimum, maximum, or transformations do time windows, time shiftings, or even resample the data. And in my opinion, a time series database also delivers high-level functions to detect outliers or trends, or do a similarity search, find similar time series. And if you're interested in some more features, there's a good blog post. It's not very friendly to read, but I think you will get the slides and you can find that blog. There are many time series databases out there implementing one or more or even all features. I've listed a few of them. For example, the RRD tool, which is mainly used in traditional monitoring systems, or Graphite, that uses some of the concepts and puts some sugar on it, more functions, better visualization. InfluxDB, which has a very handy query language that is similar to SQL. OpenTSDB, it's based on an HBase and Hadoop or even Prometheus. So I see it's not an old link to SciDB. It's just a first time series database used in scientific for scientific reasons, or KairosDB, which is a rewrite of OpenTSDB, and Netflix, Atlas, and Druid, and DalmatinaDB, and of course Chronix. So why did we create our own time series database instead of using one of these? The answer is simple. The tool I've shown on the second slide has been around for a good few years, and there was no time series database that complies our requirements, and sadly there is no one today. So that's the reason why I stand here and tell you something about Chronix. And what are our requirements? Of course, we want fast write and query performance. Well, what does Apache Solr delivers? It's well known that Apache Solr and even the underlying Lucene is very fast. We want that the database runs on a laptop computer. That is also achievable with Apache Solr, as it runs even embedded, standalone, or distributed. As the whole database should run on a laptop computer, we need that the data is stored highly efficient. And Lucene, the index itself, is very small, has a field compression built in, so check. We want to store arbitrary attributes. It's also possible. And we need or want a query language for describing complex terms on the attributes. For example, we want to do wildcard searches. We want to combine terms using Boolean operators, and all that comes with the Solr query language. And if you build a tool on a platform or a further tool like Apache Solr, you have to check if the community is large and if the application has an active development. And LucidWorks maintains Apache Solr, and it's, as the name suggests, an Apache project. And there are so many more features that comes with Apache Solr. Even in the latest version, they introduced a native SQL support, so you can use JDBC to query for data on an Apache Solr cluster. And an alternative to Apache Solr is Elasticsearch. Elasticsearch is also based on Lucene. The products are quite similar, so if you want to replace Apache Solr in our approach, one should choose Elasticsearch. Well, let's dig deeper into the internals of Chronix. That's the architecture from a high-level point of view. We have 4 stages. The first stage is called semantic compression. Semantic compression has the objective to reduce the points of data, and even if accuracy is lost. And that's the point why the first stage is optional. And if one applies a semantic compression algorithm, like Fourier transformation or averaging, one has to ensure that the query asks the data can deal with the lost information. The second stage, called attributes and chunks, splits, for example, 1 million points into 100 chunks, and each chunk contains 10,000 points. And it also calculates the attributes that describe the chunk and put them together into a logical record that is later stored in the record storage. And the third stage, called basic compression, uses standard techniques like gzip to compress the data, and on time series data one can easily achieve compression rates of about 69%. And the last stage is the multidimensional storage. That means that the attributes remain untouched, the data remains untouched, and the attributes are represented as dimensions. So each attribute is a dimension and could be searched within the storage. And one can see that the record is the key data element of Chronix, and it's simply a key value map. The data, as mentioned before, contains the binary large object of our data objects. So if you want to store a time series, a typical time series of timestamp and numeric value, you can use the typical time series. Or if you want to store calls and exceptions, for example, which are traces, you can store them also in a binary large object. So Chronix has no information about what is inside the chunk. Or you can store any kind of complex data you can imagine that have a time dimension. Of course, we have some technical fields that comes with Apache Solr, for example, the ID and the version, and we have 2 required fields describing the first point in the chunk and the last point of the chunk, called start and end. And as mentioned before, we can store optional attributes. They make the chunk searchable, they are indexed, and can also contain pre-calculated values. For example, if you have a query that query, for example, the maximum, and you do that query every day, you can think about it if you pre-calculate that value, so that the query can access that pre-calculated value of the chunk instead of loading all the data from the hard drive, decompressing it, and deserializing it. And with that, one can speed up queries. And it's also important that one has typical functions to work with time series data. And in Chronix, I split them up into aggregations and analysis. And there are typical aggregations like the minimum, maximum, percentiles, get the bottom or top n values, above or below a value, or calculate the range, the value range of a time series. And there are also high-level analyses to query all time series that have a positive trend, for example, have an outlier, or use fast dynamic time warping to search for time series that are similar. And you can also do a vectorization. Means, for example, if you have a client with a tiny display, you can do a server-side vectorization to reduce the data amount, so that the client can handle the time series data. So what if you have a time series that has a specialized form that only you have, and you want that Chronix stores that time series? In that case, you have to implement an interface with two methods called from and to, and you get a binary time series chunk, which is the record, the representation of the record. It's a map of key value with the compressed data blob and all attributes. So you only have to describe how to convert that binary time series into your special time series and vice versa. And with Chronix we have implemented, or we have a time series framework called Chronix Cassiopeia. It can be used with Chronix or without Chronix, and it comes with 3 time series types. Of course, the numeric time series with doubles. One can store thread dumps or even S traces, dumps from S traces. For example, the idea is that if you detect high CPU load, you can also call Chronix or ask Chronix for give me the most frequent system calls in that duration, in that time range. So if you want to execute Chronix on your laptop computer, that's the execution view. You have your computer, you need Java runtime environment and version 8 and Chronix. And as one can see, Chronix is only a Solr server with 3 custom plugins. One has the query handler that implements all the functions. One has the Chronix response writer that allows one to typically Solr reports, if one uses the HTTP interface, uses the JSON, and the data is serialized as base 64. But in the case that I want to use Grafana as my dashboard, I need a way to say, Chronix, give me the data deserialized and decompressed. And this is the part of the response writer. The response writer decompresses and deserializes the data and serializes it as JSON. And of course, one can use binary and binary. And we have a small retention plugin that deletes time series that are older defined threshold. And Chronix is a young open source project, and we only have one native client in Java. And I want you to show how to use that client. One first has to define a connection to Solr using the standard Solr API and a Chronix client. The first argument is the converter. Cassiopeia simple converter is the default for time series of numeric values, and one has to define the Chronix Solr storage that queries Solr and does the conversion and so on. Currently, we have a second implementation, or we have 3 implementations of the Chronix, of the storage interface, even for Solr, for Lucene, and for Spark. And one has to define a function to group the records and reduce them. And one can use any combination of the attributes to group the chunks. So if you want to do a range query, and you want to get all metrics whose metric name contains load, we define a standard Solr query, define the expression, and call stream on the client, and the result is a Java 8 stream of time series. And if you want to do some aggregations, we use the filter query mechanism, and we pass our expression. In that example, we want to get the maximum, the minimum, we want to count the time series, and we want a signed difference of the time series. That means if the first value is 20 and the last value of the time series is minus 100, the signed difference is minus 80. And the way how we stream the data is similar to above. So I have a small screencast of how Chronix performs. I hope you can see the input. So, okay. So I've pasted in a range query with a defined start and a defined end, and for one specific time series load average. And the query took 12 milliseconds. In that case, we replaced the end with now, which is a special keyword used by the Lucene date math. We can also subtract 2 years. As you can see, the data is old, but not too old, so minus 3 years returns an empty query. So we're going to replace the end with the former date string. And what we now do is do a wildcard query. So we want all metrics whose metric name contains load. That are 3. And the query time was 40 milliseconds. And we can also express the query with Boolean operator. So we want all metrics, all time series that have a max or an average in its name. And what we're now going to do is call some aggregations on all time series that matches the query above. For example, we want the maximum of the maximum, the maximum of the minimum, and the maximum of the average. And we also can pass a further aggregation. We want the maximum and the minimum. We'll get 6 time series for the three time series from the query above. Now we pass an outlier detection to Chronix. Delivers all time series that have an outlier. The query itself took 51 milliseconds, but the charting engine is very slow and took 11 seconds. So, and the last analysis query is doing similarity search using fast dynamic time warping. And we want to find all time series that are similar to load maximum. And, well, okay, it's not so special that the minimum and the average load is similar to the maximum load. But, okay. But that, why did I choose that small data set? That's the data that is shipped with the release. So everyone who wants to play with Chronix and repeat that could download the latest release and execute the queries. And using the Java FX example to visualize and explorize the time series data. So if you want a more powerful way to work with time series data, you can use a Chronix Cloud. You can use a Spark cluster and an arbitrary workbench, for example, Apache Zeppelin. And as mentioned before, Chronix is simply an Apache Solr with 3 custom plugins, so we can use the standard cluster mechanism of Apache Solr. And if you have set up a Spark cluster, you can use Chronix Spark that delivers a Chronix Spark context that connects Spark with Chronix. So you can query data out of Chronix and process in a Spark cluster. And furthermore, you can convert the Chronix Spark context into a Spark SQL context, which allows you to use the SQL features of Spark. And on that you can use Zeppelin to play with the data, or you can implement a plain Java application or a Scala-based application. And that's the second code slide and the last code slide. What has to be done to bring them all together, excluding all the infrastructure stuff? You have to set up Chronix, and you have to set up Spark. This is Java Spark context. You have to set up the Chronix Spark context and an SQL context. And if you want to do the same as in the former example, we want all time series that whose matrix contains load. We define the Solr query, and we call on this Chronix Spark context query Chronix chunks, which in difference to the single Solr instance or a single Chronix instance delivers chunks for a higher parallelism. And for that we use the Chronix Solr cloud storage. And then we can play with the data. For example, as mentioned, we can convert the RDD to a data set to use the SQL features. We can call mean, maximum, or get an iterator over the time series data. So I want to show you how to tune Chronix or what we did to tune Chronix to gain its best performance results. Chronix can be used with various compression techniques and chunk sizes. And it's clearly that these are the 2 tuning parameters, called T for compression technique and C for chunk size. And we have used a data set from 3 real-world projects, about 15 gigabytes of time series data in raw data, uncompressed. That's about 500 million points in about 15,000 time series. And we have collected typical queries that are asked, for example, with tools like the software EKG, asking for different time ranges with different occurrence. For example, a query asking for 1 week of data is asked 10 times, while a query asking for 3 months is only asked twice, to represent a real query mix. And then we have measured the compression rate with the different compression techniques and different chunk sizes. And even the total time that is needed to answer the 92 queries with the compression techniques and with different chunk sizes. And that's are the results. We first have measured the compression rate. So we have imported the 15 gigabytes of time series data with different chunk sizes. And as one can see, nearly all compression techniques achieve high compression rates. But what is more important for us is the query time the overall query performance. And it's shown in the second chart. And this chart is missing bzip2 and xzip. While these two algorithms are times slower than gzip, lzip4, or snappy. And one can see that gzip has the best overall performance in query time with a chunk size of 128 kilobytes. So the default parameter values are gzip and 128 kilobytes. And for all that are more interested in the tuning and what we did, you can check out our research paper about Chronix. And of course, we have compared Chronix to related time series databases. We have evaluated InfluxDB, Graphite, OpenTSDB, and KairosDB. And all databases are configured to run as a single node. That's an important point, as one may say OpenTSDB is optimized for distribution with tens of nodes and TSDB clients. Well, what we want to measure is the performance on a single node. So we have imported the 15 gigabytes of data, and Chronix needs 237 megabytes to import 15 gigabytes of data. And the related time series databases need 4 to 84 times. More space, of course. And Chronix needs less space. Yeah, that's right. What we have done, what we have then measured is the query time for the 92 queries. We have imported data to all databases, and we have asked all databases for that queries. And Chronix is 50 to 91% faster than the evaluated databases. And the further important measurement is the memory footprint of the databases. So we have measured 3 points of interest shortly after the start of the time series database, the maximum during the import, and the maximum during the query. And on that, Graphite is the best time series database. We have summed up all the 3 values, and it takes 926 megabytes. Chronix needs 1.5 gigabytes, and the remaining 3 needs 16 to 39 gigabytes of memory. Well, I know that this slide is a summary, and the hard facts are in the paper. So again, if one is interested, I suggest you to read the research paper called Chronix Efficient Storage and Query of Operational Time Series Data of Time Series. The state is currently submitted, so I have no idea if it will be accepted, so hopefully. So, now it's your turn. So, are there any questions? So I have 5 minutes to fast, but are there any questions about Chronix?
Very much.